Hello, myself Vaishnavi. I'm currently pursuing my BE in Sri Venkateshwara College of Engineering. Today I'm going to do the topic on angle between two lines of regression. Topics to be covered are introduction, lines of regression, formula for the lines of regression, angle between the lines of regression, types of correlation and angle of regression, and the problem related to it. Before knowing about the topic, let us know where this lines of regression is used in engineering. Linear regression is a mathematical method that is used by engineers frequently to reverse engineer data from which comes from an unknown source. Regression analysis is a reliable method of identifying which variables has an impact on topic of interest. The process of performing a regression allows you to confidently determine which factor matters the most, which factors can be ignored, and how these factors influence each other. This lines of regression is also used in daily life such as analysis of relationship between variables. Linear regression can also be used to identify relationship between different variables. Regression. Regression is a statistical method that is used in finance, investing, and other disciplines that attempts to determine the strength and the character of the relationship between one independent variable that is usually denoted by y and a series of other variables that is known as independent variables. A regression model is able to show whether the changes observed in the dependent variable are associated with the changes in one or more of the explanatory variables. Angles between two lines of regression. Forecasting or prediction is a crucial part. We also try to stay ahead of the things we plan. Although which this is a simplified version of the concept of mathematical regression. Regression means going back or taking a step back. Regression analysis is a mathematical way of establishing an average relationship between the independent and the dependent variable. We can use this relationship to predict the future results or the study past data. In this article, let us learn about the lines of regression and the angles between them. What are these lines of regression? If this curve of a straight line, it is a case of linear regression, and the straight line is called the line of regression. The regression lines are the lines that fit the best, so they try to cover as many points as possible from the scatter diagram as possible. These lines express the average relationship between the variables. In linear regression, we find the lines of regression by the concept of curve fitting using the principle of least squares. Why are there lines of regression? This method of the least squares minimizes the sum of the squares of the errors from the specified value depending upon which variable we select as independent variable from x and y. There can be two lines of regression, that is, line of regression of x on y. We use this line to find the value of the dependent variable x on the given value independent variable y. We use for the least squares method to minimize the squares of the errors of the available values of y from the mean value of y, that is y bar. Lines of regression of y on x. We use this line to find the value of dependent variable y for the given value of independent variable x. We use the method of least square to minimize the squares of the errors available for the values of x from the mean value of x, that is x bar. The representation of x and y. This line represents the line of regression of y on x, and this line represents the line of regression on x on y. Formula for the lines of regression. We know that the line of regression of x on y is given by the equation x minus x bar is equal to r sigma x divided by sigma y into y minus y bar. The line of regression of y on x is given by the equation y minus y bar, that is equal to r sigma y divided by sigma x into x minus x bar. Here, x bar represents the mean of the values of x. Y bar represents the mean of the values of y. Sigma x represents the standard deviation of the values of x from x bar. Sigma y represents the standard deviation of the values of y from y bar. And last, R represents the correlation of coefficient. According to these formulas, we can see that the both of this line passes through the point x bar and y bar. Thus, this is the point of intersection of line, and this line represents the regression of y on x, and this line represents the line of regression of y on x, and this point is represented at the point of intersection, that is x bar and y bar, where these two lines passes, it is represented as x bar and y bar. Let us derive the equation for the angle between two lines of regression. We have seen that two lines of regression intersect at the point x bar and y bar. Therefore, there is a correlation that is not perfect. The two lines will be at an angle theta at each other, and this line represents the theta, where this point represents the point of intersection x bar and y bar. We know that the line of regression x on y is given by the equation x minus x bar, that is equal to r sigma x divided by sigma y into y minus y bar. Coming to the formula, the line of regression of x on y is given by the equation x minus x bar is equal to r sigma x divided by sigma y into y minus y bar. Let us represent the slope as the line m1. We can rewrite the equation as y minus y bar is equal to sigma y divided by r into sigma x into x minus x bar. Let us compare the standard line equation, that is y minus mx plus c. We get that m1 is equal to sigma y divided by r into sigma x. Similarly, this line of regression y on x is given by the equation y minus y bar, that is equal to r into sigma y divided by sigma x into x minus x bar. Let us consider this slope as the m2. Now, considering this line as a standard line equation, y is equal to mx plus c, we get m2 is equal to r sigma y divided by sigma x. For the two intersecting lines of the slope m1 and m2, the angle between the two lines is theta. We can found it by the formula tan theta is equal to m1 minus m2 plus divided by 1 plus m1 into m2. We have already found the value of m1 and m2. Let us consider from the given equation 1 and 2, that is tan theta is equal to mod of sigma y divided by r into sigma x minus r into sigma y divided by sigma x divided by 1 plus sigma y into r into sigma x into r into sigma y divided by sigma x. Now taking the common sigma y and sigma x, consider in the brackets 1 minus r divided by r into 1 plus sigma square divided by sigma x square. Tan theta is equal to mod of sigma y divided by sigma x into 1 minus x r square divided by r into, let multiply this 1 and sigma x square divided by sigma square x divided by sigma square y. Tan theta is equal to mod of 1 minus r square divided by r into, calculate both of this, and we'll get the value sigma x into sigma y divided by sigma x square plus sigma square y. So the tan theta value will be arrived as tan inverse of mod 1 minus r square divided by r into sigma x into sigma y divided by sigma square x plus sigma square y. Types of correlation and angle of regression. The following are the different types of correlation and angle of regression. First, let us consider or substitute r is equal to 0 for the equation theta. We get that in place of r we need to consider 0. So we'll get the value theta is equal to tan inverse, that is not defined, and a tan inverse formula is theta pi by 2. It means r is equal to 0. The angle between these lines of regression theta is equal to pi by 2. So r is equal to 0 means the variable x and y have no correlation. If we substitute r is equal to plus or minus 1 in the given derived formula, theta is equal to tan inverse of 0. Then we get theta is equal to 0 or theta is equal to pi. If we consider this r value as plus or minus 1, then the lines of regression of theta is equal to 0 or pi, which means r is equal to minus or plus 1 means the variable have the perfect positive or perfect negative correlation. Thus, for perfectly correlated means positive or negative variables x and y, the lines of regression are coincident. As the angle between the two lines of regression decreases from pi by 2 to 0, the correlation between the variables increases from 0 to 1. As the angle between the two lines of regression increases from pi square divided by 2 to pi, the correlation between the variables increases from 0 to pi. Let us solve the problem that is related to the lines of regression. For two variables x and y, the correlation coefficient is 0.5. The acute angle between the two lines of regression is tan inverse of 3 by 5. Show that sigma x is equal to 1 by 2 sigma phi. Let us consider in the given data that is considered that correlation r is equal to 0.5. The angle between the two lines of regression is theta is equal to tan inverse of 3 by 5. Substituting these angles in the equation of theta of the given, we know that the given formula for the angle between two lines of regression is theta is equal to tan inverse mod of 1 minus r square divided by r sigma x into sigma y divided by sigma square x plus sigma square y. Since this angle is acute, we can write that removing the mod, then tan inverse of 3 by 5 is equal to tan inverse of 1 minus 0.5 square divided by 0.5 into sigma x into sigma y divided by sigma square x plus sigma square y. Now taking the value, cancelling the tan inverse and the value remaining 3 by 5 is equal to, and writing this value and squaring of the value 0.5 into 0.5 is 2.05, and dividing this value 1 minus 0.25 divided by 0.5 will get the value 3 by 5 is equal to 3 by 2 into sigma x into sigma y divided by sigma x square y into sigma plus sigma square y, and cancelling the value 3 and 3 we get 2 into shifting this value sigma square x plus sigma square y is equal to 5 into sigma x into sigma y. Multiply this 2 into this and 2 to this and 5 to this. We'll get this value. And sigma square x plus minus 4 sigma x into sigma y minus sigma x into sigma y plus 2 sigma square y is equal to 0. So taking the common, sigma x minus 2 sigma y into sigma x minus sigma y is equal to 0. So the final value after the solving we derive is sigma x is equal to 1 by 2 sigma y. Thank you.